Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking express the following numbers in polar form. Here we have numbers given in polar form. This one is already in polar form, but however we have to convert this one into one number because we have two complex numbers. So we have to convert this one into one number. In order to do this one, the best approach is we convert this one into rectangular form first, then we convert back into polar form, because in rectangular form we can add this one easily. Okay, now let's go ahead and convert this one into rectangular form, but in order to do that we have to know Euler's identity. Euler's identity says that whenever we have r e power j theta, that can be written as r times cos theta plus I times j sin theta. Oh, not I time, I or j. Like engineers use j and others mathematicians use I, because I is already taken for the current in engineering, so we use j for the I. That's the imaginary part. Now let's go ahead and do this one. Now let's go ahead and convert this one into this pattern. Okay, for the first one, here we have two complex numbers. That's the first thing you have to realize. This is one complex number and this is another one. Now what we have to do is we have to convert this one into this pattern. For this one you can see the coefficient is equal to 1. So we are going to have r is equal to 1, and then we are going to have cos, the angle is 5 over 4. So cos 5 over 4 plus j sin 5 over 4. Okay, so this is the first one. Now let's look at the second one. Second one is 2 times e power negative j 5 over 4. So here we are going to have the angle is negative 5 over 4. So this is going to be cos negative 5 over 4 plus j sin, and you also have to know when we have cos negative theta, that's equal to cos theta, and when we have sin negative theta, that is equal to negative sin theta. So we can write in that way, it will be much better. So cos negative 5 over 4 is equal to 5 over 4, but sin negative 5 over 4 is equal to minus j sin 5 over 4. In that way it will be easier to convert. Now cos 5 over 4 is going to be 1 over root 2, j 1 over root 2, sin 5 over 4 also same thing, and then 2 1 over root 2 minus 1 over root 2. Right, so this is j and this is also j. Okay, let's add them together. For the first one, 1 over root 2 plus, this is the real part, these two are real parts. So 1 over root 2 plus 2 1 over root 2, that's going to give us 3 over root 2. So this is our real part. Let's add the imaginary parts. J 1 over root 2 minus j 1 over root 2, and I forgot to do one thing. When I do the multiplication, this is for whole thing, right? Because if you look at this one, r times cos theta j sin theta, this is for the whole thing, so this should be 2 right here. Okay, so 2 mean 1 minus, here we have 1 j 1 over root 2 minus 2 j 1 over root 2, that's going to give us negative 1 j over root 2. So this is going to be the complex number we are going to derive. Now we have the complex number, so it's easy to convert this one back into polar form. Okay, now to convert this one into polar form, first we have to know what's the angle, and also we have to know the distance, because in rectangular form we are looking at the location. For example, if I put this one in a graph, let's say 3 by root 2, that's the real part, right? Real part always in the x-axis, so it's going to be somewhere, let's say this is 3 by root 2, and negative j root 2 mean this is in the y-axis, this is the imaginary part, this is going to be somewhere here, 1 over root 2. Now the point is the rectangular form, but when we convert this into polar form, we have to find out what is the distance, because when we express in polar form, we are expressing in terms of distance and the direction from the origin. Okay, there's another way to also, you can put the direction like in this way. If you put this way, you have to put a negative sign. Now first we have to calculate the distance. To calculate the distance, we use the Pythagorean theorem. That's going to be what we are going to have. Z is equal to square root of 3 by, it's actually 3 divided by root 2. So 3 by root 2 square plus minus 1 over root 2 square, and if you calculate this one, you're going to get root 5. So this is our distance. Now we have to find out the angle. To find out the angle, we can use the tan theta, since we have the opposite and the adjacent available. So tan theta is going to be what? Opposite is negative 1 over root 2. 1 over root 2 divided by adjacent is 3 over root 2. And therefore theta is going to be tan inverse of negative 1 over 3. And that's going to give us the angle negative 18.4 degree. 18.4 mean this is counterclockwise. That's why we are getting a negative answer. So this means this angle is negative 18.4. We can express the answer in terms of this negative, or you can subtract this value from 360 and express the final answer in terms of this angle from this side, counterclockwise. So both ways it's correct. So finally we can express our answer as this, like root 5 is the distance. We have to have r and the e power j theta, and this is our angle. So root 5 e power negative j 18.4. So this is going to be the conversion of the complex number. Like when we add these two together, this is what we are going to get. Okay, now let's look at the second one. Second one, we have to do the same thing, because this is a complex number. Here we have a normal number, but we have to add these two together and see what's the final polar form of the complex number. In order to do that, first we have to convert this one into rectangular form, then we have to add them together. Okay, now let's get rid of these parts because we need some space. Now we are going to do the B part. Okay, let's go ahead and do that. Here again we need the Euler's identity. That's given by r e power j theta is equal to r cos theta plus j sin theta. Now let's look at the second one, B. Okay, B is what? Z is equal to e power j plus 1. What is our coefficient right here? Coefficient is 1, right? So 1 is the r. Then cos theta is going to be j, and here we have j alone. So this is mean that angle is 1, but that is in radians. So we just going to put cosine 1 plus j sine 1 plus 1. Now let's see what we get. If you plug this one into calculator, like if you convert this one into angle, or you can directly calculate using, but let's convert this one into angle. If you convert this radians into angle, you will get 57.3 degree, and then j sine 57.3 degree plus 1. And if you calculate this value, you're going to get 1.54 plus j 0.84. So this is our derived rectangular form of the complex number. Now we have to convert this one into polar form. Again we are going to do the same thing. Like if I draw this one in a graph, this is our real part. Real part, let's say this is somewhere here. Real part should be in the x-axis somewhere here, and the imaginary part is somewhere here. So this is our complex number. This is in terms of the location. Now we had to, when we convert this one into polar form, we are looking at in terms of distance and the direction. So let's call this one r, and the direction is going to be from here, or we can express from here to here. If we express from clockwise, we have to put a negative sign, and from here to here we had to, it's going to be a positive sign. Let's see what we get. In both way we can express. So whenever you plug in calculator, if it gives you negative answer, it means it's giving you from here to here. So in that way you can express in this way too. Now let's look at the r distance. We know this is equal to what? 0.84, and this is equal to 1.54. So r is going to, we are going to use the Pythagorean theorem to calculate r. R is going to be equivalent to this. R is going to be equivalent to this one square, 1.54 square plus this is positive 0.84. So it should be in the upper direction. Okay, so this is 1.54, but this is positive 0.84. So we are looking at R somewhere here. Okay, R is here. 1.54 square, 0.84 square. So finally we will end up with 1.755. So this is going to be the length of this distance. Now we have to find out the angle from here to here. Let's call this one theta. So tan theta is going to be opposite, that is 0.84, divided by the adjacent, that's 1.54. Therefore theta is going to be tan inverse of this, 0.84 divided by 1.54, and that's going to give us 28.65 degree. So we have the angle and the R value, that's distance. So we can finally express our complex number in polar form like this: 1.755 e power j theta, j 28.65 degree. So this is going to be our final answer. And that's it for this one. Now let's look at the third one. Third one we have to do the same. It's in the polar form. Actually it's in the rectangular form. First we have to convert this one into polar form, then we have to see whether we can simplify this one. Okay, let's see. Okay, let's get rid of this one. Okay, so first of all, to convert this one into rectangular to polar, we are looking at part C. So to convert this one into rectangular to polar, what we do is, first let's look at the top part in the graph. So one in the real part and one in the imaginary part. So let's say somewhere here, and we are interested in this location, in this distance and location. So this is going to be what? R is going to be 1 square plus 1 square, that's going to be square root of 2, and then theta is going to be tan inverse of 1, that's going to be 45 degree. Okay, so this is going to be what we are going to get: z is equal to square root of 2 e power j 45. That's going to be the numerator. Now let's look at the denominator. Okay, so here we have negative 4, that's our real part. Imaginary, real part is negative 4, it should be somewhere here, and then the imaginary part is positive 3, it should be somewhere here. So the complex number is somewhere here. So we are looking at the length of this one and also the distance from the origin. Okay, length of this one is easy. This is a 4-3-5 triangle, so you can directly see it, or you can use the Pythagorean theorem. That's going to be 4 square is about 16 plus 3 square 9, so 25 square root, you will get 5. So this is 5, that's our R. R is going to be 5. Then angle theta is going to be tan inverse, the imaginary part, that's going to be our opposite, so 3 divided by adjacent, that's going to be negative 4, and if you calculate this angle, you are going to get negative, okay, actually 143.13 degree. So we have the angle, okay, 143.13 degree. So we have the angle and the length, so we can express this one in terms of polar form. So this is going to be 5 e power j 143.13. Now we have two complex numbers dividing each other. This one is easy because square root of 2 divided by 5 remains the same, but when you divide exponential, that's going to subtract each other. So we are going to have e power j 45 degree minus j 143.13 degree, and if you subtract these two, you are going to get, and if you simplify this one, this is going to be 0.2828, and if you subtract these two, you are going to get e power j, actually negative j 98.13 degree, and that's going to be our final answer for this one. I hope this helps. Thanks for watching.